We here at Jovo's Engineering Design Industries, also known as J.E.D.I, were tasked with the project of redeveloping the County Health Services Complex, located between Rosecrans Street and Pacific Highway in Old Town San Diego. The plan that we proposed and designed for the County of San Diego involved demolishing the old County Health Services building, building a 4-story high live-well center, and allotting space for a new parking structure and a new affordable housing complex. However, we cannot start building without redeveloping the site first. Here is Sharon, our site civil engineer for this project.
The site is approximately 7.1 acres. One of the responsibilities of the site civil engineer was to produce a fine grading plan. The original grade was at 10.36 feet at sea level, but the site was graded down 1% to incorporate the bioswale. The new grade is now at 9.5 feet at sea level. The cut area is 3,999.47 cubic yards, and the fill area is 565.05 cubic yards. The site needed to be demolished to incorporate 3 new buildings. The demolition will take place in 3 phases. The first phase includes demolishing the current parking lot for the new Livewell Center, while keeping the current building in operation. The second phase takes place after the new health services building is built. In this phase, the current building will get demolished. The third phase will take place after the parking structure gets built, and then the back parking lot will be demolished to include the affordable housing. This parking serves as the temporary construction and staging. The new utility plant connects 6 12-inch corrugated pipes from the bioswale to the main storm drain. From the new building, there is a 10-inch PVC pipe connecting to the water main and an 8-inch PVC sewer pipe to the city sewer main. The engineer's estimate that is provided only accounts for the materials needed to grade the new site, build the building shell, stormwater, water, and sewer pipe sizing, all of which came to a total cost of $18,616,927.64 based on the San Diego County unit price list as well as the City of San Diego unit price list.
Thank you, Sharon. We now know what to do for the surface of the site, but what about the subsurface? To explain the geotechnical side of our project, here's Guillermo.
For the construction of the County of San Diego Livewell campus and parking structure, we will use deep foundations, the highest capacity foundation system, better known as piles. Drill piles will be constructed to transfer the structural loads into the ground and have the soil support the structure. The planning and design of foundations were based on the layer interfaces and parameters below the ground surface calculated from data obtained from cone penetration test, also known as CPT testing. The selection of piles was based on soil conditions. The site subsurface has been classified as being composed mostly of sand. 4 layers were found with similar soil parameters. Therefore, our solution is to choose the highest capacity of foundation systems. For the design of piles, it is our recommendation to design as conservative as possible. Therefore, our team of designers in both geotechnical and structural departments suggest square cross-sectional piles of rough concrete with a width of 3.28 feet and length of 44 feet to support a load of 35.5 tons force from each of the columns.
After learning about the subsurface of our site, it's now time to build a building upon it. Here is our structural engineer, designer of the building shell on top of the site and the piles that go below it.
Hi, my name is Joseph Tan, and I'm the lead structural engineer of this project. Our scope of work includes designing a building shell for the proposed Livewell Center. The final design for the Livewell Center consists of a 4-story building with an approximate square footage of 260,000. Each floor is 15 feet high. With the slab and beam thicknesses included, the floor-to-ceiling height is 12 feet. We use several codes and standards as our basis of design. The 2016 version of ASCE 7 from the American Society of Civil Engineers was used for minimum design loads. Because the main building material of our structure is reinforced concrete, ACIA 318 from the American Concrete Institute was referenced for design standards. Reinforced concrete was used due to our experience in reinforced concrete design. Additionally, we looked at California's Office of Statewide Health Planning and Development codes regarding designing hospital and clinic buildings. Other codes that we incorporated include the California Building Code, International Building Code, and San Diego Municipal Code. The load and resistance factor design method was used to ensure an adequate factor of safety. First, we calculated the live and dead loads of the structure using the loads from the ASCE 7 Table 4-3-1. We assumed that the Livewell Center would consist of corridors, laboratories, patient rooms, offices, and lobbies. As mentioned before, reinforced concrete was the material chosen for structural elements. The design compressive strength of the concrete used is 4 kips per square inch. The unit weight of our concrete is 150 pounds per cubic foot. For rebar, A615 grade 60 was used, with a yield strength of 60 ksi and an ultimate tensile strength of 90 ksi. To be on the conservative side, we use the same section for each structural element. The live well center will have 5 slabs, 1 slab per floor, and a slab on grade. The slabs are 8 inches, with an effective depth of about 5 inches. The rebar and shrinkage steel sizes are number 9 with a center-to-center spacing of 12 inches. To support the slab loads, beams are underneath the slabs and connected to columns. A total of 432 beams have been designed. The beam specifications are a span of 35 feet, thickness of 27 inches, effective depth of 23 inches, width of 16 inches, and clear cover of 3 inches. Long spans are used to maximize the amount of usable space in the building. For reinforcement, 5 number 9 bars are used for longitudinal reinforcement, 2 number 4 stirrups are placed at 8 inches center to center for shear reinforcement, and 2 number 7 hanger bars hold up the stirrups. 72 columns hold up the building shell. Square tied columns with a length and width of 2 feet shall be used. Due to the high amounts of load, 10 number 18 bars have been chosen for a longitudinal reinforcement. Number 3 ties placed at 18 inches on center provide transverse reinforcement. Under the surface grade are piles. Based off the geotechnical report, the live well center is underlain by liquefiable soil. To counter this, we designed deep pile foundations that are embedded about 2 feet into the rock. The height of the pile is approximately 45 feet. The length and width are about 3 feet, and the main reinforcing bars are 8 number 7 bars. To resist earthquake loads, we accommodated room for shear walls that can be placed anywhere in the structure. The structure that the J.E.D.I structural team designed is built to last thanks to our conservative approach.
After designing and building the clinic, we will now determine the amount of water needed by the building's occupants. To get this info, we will talk to Leah Marie, our water and sewer engineer. We will start with her water study.
J.E.D.I's engineering design industries will be tasked to analyze the water demand for the projected population of 800 clients and staff, and through that, determine the pipe sizing for the area. According to the City of San Diego Facility Design Guidelines, the standard pipe sizes for the water mains are as shown. Based on calculations performed using the flow rate equation Q equals VA with an assumed velocity of 15 feet per second, the diameter was found to be about 10 inches, leading to a material of PVC pipe to be used on the site. The fire flow demand of 4,000 gallons per minute was taken into account for holding a capacity of both potable water and fire flow. In addition, a variant of the head loss and Bernoulli's equation was used to find the pressures within the pipes. As a result, also, a 6-inch water lateral would be proposed to connect to the new Rosecrans Live Well Center.
Now that she is done with her water study, let's hear about her sewer study.
Due to an increased population of 800 staff and clients, J.E.D.I's engineering design industries was tasked to analyze the current existing conditions of the sewer mains in order to determine whether or not the sewer pipeline should be altered to meet the demand of the sewage quantities of the projected population. For the existing conditions, an 8-inch PVC pipe was assumed to be the pipeline surrounding the site. This assumption was based on the standards from the City of San Diego Sewer Design Guidelines. The design criteria are as follows. Peak dry weather flow was calculated to determine the sizing of the pipe and lateral. The results showed pipe sizing does not need to be altered to meet the projected demands. According to the sewer capacities chart, a peak dry weather flow of 113.3 gallons per minute yielded a pipe size of 8 inches.
Thank you, Leah, for your information on the clinic's water and sewer needs. However, these are not the only aspects of the project with regards to water. Here is Cheyenne with information on the site's hydrology and stormwater.
In the initial assessment of the 7.1 acres and during the site visit, 5 storm drains were found on site and 2 directly off site that could catch flow. With this information and topographic maps, it was determined that the site had 4 drainage basins and a hydrologic area of 9.39 acres. The runoff rates were calculated for 2, 10, 50, and 100-year storms. For feasibility, J.E.D.I decided to use 50-year storm runoff rates for existing site conditions to compare to the proposed. To compute the runoff rate, the rational method was used from the San Diego County Hydrology Manual. Intensity duration maps were used to get intensity along with isopluvial maps. For the existing site, the 50-year storm runoff was 26.91 cubic feet per second, and for proposed, it is 21.162 cubic feet per second. The pervious surface area of the site was increased from 2.34% to 5.1%. This was due to adding 23,000 square foot of vegetated area, which includes 852 square foot of a bioswale. The bioswale was designed according to the Caltrans BMP manual and San Diego City Stormwater Standards manual. The bioswale contains 3-foot by 10-foot filtering media of gravel, a 6-inch layer of dirt, a geotextile fabric, drought-tolerant plants, and 6 12-inch corrugated pipes that will connect to the city storm drains where runoff will be carried away.
Hydrology and stormwater are not the only parts of the project that take into account flow. The traffic study also accounts for the flow of vehicles entering and exiting the site. Let's hear more about it from Michael.
In order to ensure that people traveling to or from the new structures for the LiveWell campus do not adversely affect the surrounding communities, J.E.D.I conducted a traffic study focusing on the level of service, or LOS, of 9 road segments. A location's level of service gives a grade, similar to a grade from school, based on the amount of congestion. The City of San Diego requires a LOS of C or higher for the road to be considered acceptable. For our 9 segments, 6 of them did not have the LOS change with the additional demand from the site, and the LOS would be considered acceptable by the City of San Diego. The Taylor Street segment would be accepted by the city, however the LOS changed from a B to a C, so traffic-reducing mitigations were proposed. In addition, the Midway Drive and SeaWorld Drive segments would not be accepted by the city, as the LOS of one changed from an E to an F, and the other is an LOS of F regardless of additional traffic added by the site. As a result, the city should make improvements regardless of this project. However, mitigations have been proposed as well. These mitigations include carpool and mass transit incentives and parking fees. Overall, it does not appear that the improvements to the site will significantly impact the local communities.
From site civil to transportation, we here at J.E.D.I always put in our best effort for our projects, and thank you for watching our video on the redevelopment project of the Rosecrans County Health Services Complex.